7th grade, this is 7.3, solving addition and subtraction equations. And I kind of think we solved some of these equations. I'm trying to remember. Probably should have checked. Sorry, I didn't mean to smack that on the desk. I probably should have checked before we did this, but I think we've solved some equations before. I'm trying to remember. Let me see here. Let me look back and see if we solved equations. We did, I think, equations and mental math. We might have done some equations. If we haven't yet, I'll remind you that equations are basic algebraic things we're trying to solve for our unknowns. So let's talk about the vocabulary. I'm on page 347 in the book. Okay, inverse operations are operations that undo each other. Okay, so inverse operations are adding and subtracting. Subtracting will undo addition. Addition will undo subtraction. Multiplication and division, same thing. Dividing will undo multiplying. Multiplying will undo division. Okay, equivalent expressions, again, are expressions that have the same value. So write the key concept. Here's the subtraction property of equality. It basically says, subtracting the same number from each side of an equation produces an equivalent equation. So check out the algebra. Negative x plus a equals b. So you minus a from this side, you would also have to minus a from the other side. So basically it's saying, if you subtract a number from one side of the equation, since it's an equation, you have to treat both sides equally. You have to subtract the same number from the other side of the equation. So let's look at it with numbers and I'll show you what I mean. Now remember, in algebra, our job is to get the letter by itself. So you find the side with the letter, we want to get this thing by itself, so there's a plus 7 right there. So I need to get rid of the plus 7, and you do that by doing the inverse operation of adding, which is subtracting. So you minus 7 from this side, minus 7 from this side. Your 7's cancel out, which is what you want them to do because you only want x on that side. But check these out. It's negative 10 minus 7. So I'm going to boom boom that because it gets, again, there's that minus, and the answer is negative 17. Now what's cool about algebra is we're going to put that into the original problem and see if it's right. Is negative 17 plus 7 negative 10? Yes, so you know you're right. And that's what's the best part about algebra right there. So let's see how they did it. You always write the original equation. They minus 7 from both sides and then got negative 17. And then they checked it just like we did. And then it works. So let's solve some of these. You ready? T plus 8 equals 15. You want to get the t by itself. So what's the inverse of adding 8? Would be to subtract 8. And if you subtract 8 from this side, remember our key concept said, if you minus 8 from one side, you got to minus 8 from the other side. Those cancel out. T equals 7. Let's put it back into the original problem. Is 7 plus 8 15? Sure is, so we know we're right. N plus 10, so you want to get rid of that plus 10, so you minus 10. You want to get the letter by itself. So you minus 10 on both sides. So N equals 4 minus 10, so I'm going to boom boom that, and it comes out to be negative 6. So we check it. Is negative 6 plus 10 positive 4? And it is. And this one, even though it's kind of turned around, you always look in front. The inverse of, to get rid of an 8. We want to get this 8 off of there, so you minus 8 from this side, minus 8 from this side. Those cancel out. X equals, you boom boom right there, negative 12. Is 8 plus negative 12 negative 4? It is. Okay, so our next box, our next key concept, is the addition property of equality. We'll check this one out. This is the same thing as the subtraction, except the subtraction says you have to, if you're going to subtract from both sides, you got to do it equally. Well, this one says adding the same number from each side produces an equivalent equation. So if you want to get this x by itself, you add a to this side, you add a to the other side. So subtract, same thing. If you're going to subtract something from one side, you got to subtract it from the other side. If you're going to add something to one side, you have to add the same thing to the other side. So basically it's just treating both sides equally. So you find the side with the letter and they kind of mess with you. They notice it's on the right side. I want this y by itself, so I have to get rid of the minus 12. What's the opposite of minusing 12? Adding 12. So you add 12, those cancel out. Y equals negative 9 plus 12 is positive 3. Let's check it out. Negative 9 equals 3 minus 12. If you boom boom that, look what you get. Negative 9. There it is. Now, fractions, it works the same way, but the deal with this in decimals is you don't want to start getting the letter by itself until you simplify the side. You can add these two because they're like terms together. So 4.3 plus 4 is 5.3 plus a equals 2. Now let's get the a by itself. Minus 5.3 from this side, minus 5.3 from this side. And you subtract, because if I boom boom, it's going to be 3.3. And it's going to be negative 3.3, excuse me, negative 3.3. And if you put it in and add all those, you will come up with 2. So you still want to simplify by combining those like terms. Notice how everything builds. That's what was from the last lesson, was those like terms. Okay? And it checks. So let's solve some equations here. M minus 6, we're going to get the m by itself. How do you get rid of a minus 6? You add 6 and you do it to both sides. So do this with me. Write them down. Cross this off. I want to see all of this. This is very important that you show your work. M equals 14. So checking our work, 14 minus 6 is 8, and it checks. R minus 10, I add 10, add 10. The 10s cancel out. R equals 24. 24 minus 10 is 14. It checks. Now this one, remember, always simplify. There's a minus and a negative, so we can boom boom that. So now it's P plus 2.2. How do you get rid of the plus 2.2? You minus 2.2. Those cancel out. P equals 3.4. So let's check it. 3.4 minus negative 2.2 is 5.6. And if you boom boom those and add them, you get 5.6. So our answer is 3.4. This one we have to combine. I'm going to boom boom this to simplify things first, make them addition, and I see the 4 and the negative 2 are like terms. So I can combine those. 5 equals 2 plus c minus 2 to get rid of it on that side. C equals 3. Let's check it out. 4 plus 3 minus 2 is supposed to be 5. 4 plus 3 is 7. 7 minus 2 is 5. And it works. Combining our like term, well, let's boom boom everything first. It just makes it easier. That's a negative 1. 2y plus negative 1 is just y. Minus 1 equals negative 3. Add 1, y equals negative 2. So we'll check it. 2 times negative 2 minus 1 minus negative 2 is supposed to be negative 3. That's all crazy. So that's negative 4 minus 1 minus negative 2. Boom, 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 boom. Negative 5 plus 2 is negative 3. That all checks. That's crazy stuff. We got one more that I can't see. Let's get rid of all my writing on the slide here. Alright, this one. I can combine this and this. You know, I see that minus just 3.4 minus 1.3. So it's S plus 2.1 equals 6.8 minus 2.1 minus 2.1. 4.7 equals S. There it is. These are fun. I could do these all day. They're so much fun to do. Okay, the Apollo 11 mission lasted about 195.5 hours. The flight from Earth to the Moon lasted about 103 hours, and the flight from the Moon back to the Earth lasted about 71 hours. About how many hours did Apollo 11 astronauts spend on the Moon? So the whole thing lasted 195.5. We don't know how long they were on the Moon, but they were on they were flying to there about 103 hours and back 71 hours. So add what we know, 174 plus x equals 195.5. Minus 174 minus 174. 21.5 equals x. 21.5 hours on the Moon. Almost a day. Let's see if our equation agrees. Yep, they just have it on the other side. 21.5. Guided practice for example 4, it says you spent a total of $50 for streamers, balloons, and flowers. You spent $12.50 on streamers, $15 on balloons. Write and solve an equation to find out how much you spent on flowers. So you spent $12.50 plus 15 plus x, we don't know, equal the total of 50. $27.50 plus x equals 50, so minus $27.50. You guys notice you do this kind of stuff all the time, you just don't think of it algebraically. $22.50 is what you spent on flowers then. There it is. So make sure, this is very, very important on this, that you show your work, and you have to show your work by first writing the original problem. Show me what you do to both sides of the equation, like this would be right here. Let me go back. X minus 3 equals 7. That's the original problem. Showing me what you do to both sides to solve it, like the adding 3. Show what you cancel, and then bring down your answer. Don't go across, bring them down, and leave room on your paper for them. Alright, so have fun. This is when it gets fun. We'll talk to you later.